Hit record. All right. We're all set. Go ahead, Brad.
All right. Good afternoon. And welcome to this, can I count quickly enough, seventh presentation in the Fall 2025 Sustainability Research and Practice Seminar. Very glad to see those of you who are here in person, and we have other folks joining us on Zoom. Thank you for making time to be with us today. Every week, the speaker brings interesting insights and new perspectives on sustainability, and I'm excited every week to introduce the speaker. This week has a little bit extra because we started this speaker series 8 years ago. We're now in the ninth year of doing this, and I thought this was the case, but I went back to our archives of flyers that we've prepared, and I did confirm that, in fact, Dr. Tim Lutz was the very first speaker in the very first sustainability. At the time, we just called it Sustainability Research Seminar. We quickly learned after that first semester that we wanted to give voice to staff and to professionals working in the world applying these principles. And so we quickly, in the very second semester, changed the title to the Sustainability Research and Practice Seminar. So that's just a little bit of history, and I'm stealing Tim's time, so I'm not going to take much more other than to say we have four more presentations this semester. Please join us as you are able. For those of you in person, if you'd like a copy of the full program, there are copies at front. And those of you on Zoom, you can find this flyer with the full program at the Office of Sustainability's website. So please join me in welcoming Dr. Tim Lutz.
Thank you. I am glad to be back after 8 years. You don't have to wait that long next time. But I do want to just start by saying thank you for having me again. And I'm happy to be here to tell you about my research on sustainability and complexity. There are some slides following the ones that I'll use in this talk, which contain some references that you might want to look at if you're interested in the topic of my talk. They're connected there. And also contact me at my WCUPA email if you'd like to talk after the talk is over. Let me see. Let me see why my screen isn't changing. There we go. Okay, so let's begin by reviewing some of the things in my title. Sustainable living, as Aldo Leopold saw it in 1938, was living on a piece of land without spoiling it. And it was an age-old problem then. And after 90 more years, we still seem to be none the wiser. And one of the things I'd like to talk about is, why is that? Why have we not really figured out this critical issue? Simplicity and complexity are seen as two poles in our thinking. Sustainable living means that society needs to find a balance between simplification, which is oriented towards creating knowledge to simplify our worldview and to control our environment, and complexity, which is an essential characteristic of planetary relationships. We place far too much weight on simplification, and we need to rebalance. I'll show you that we can learn to rebalance the benefits of simplification with those of a complex worldview, which I call complexability. And I'll show you how we can start including that in envisioning new goals. To me, the need to rebalance our worldview is best indicated by the divergence of two key trends in the human condition: overall improvements in healthcare, life expectancy, education over decades and centuries seems like good news. This is the futurist's perspective, right? We've done great and we're going to do even better as time goes by. But along with those trends, of course, there are others that we're more familiar with in sustainability, opposing trends that include climate change, environmental injustice, loss of biodiversity, and pollution. And these are indicators of an unsustainable path that undercuts all of those advances that we seem to be making. And I want to ask, why did these opposing trends develop? What strikes me about these trends is that they mostly originated from advances that, when they were started, were meant to make the world a better place by providing water and electricity to all, increasing crop yields, making healthcare and other goods more available. While we may appear to have been ignorant, careless, biased, or greedy in the past, we have to wonder, are we doing any better now in our pursuit of sustainability? Are present-day advances, such as renewable technologies, geoengineering, and artificial intelligence, going to be the boons or the banes of our future existence? No single component of the polycrisis, such as climate change, is the problem we face. All components are symptoms of problems at a higher level. To work at that level, we need to take a broad philosophical approach that grapples with the normalized assumptions we might not even consciously know that we make. I won't have time to acknowledge and explain the work of all those who've influenced me, but you'll find references to key works by each of them at the end of the talk. Among them, Paul Cilliers stands out for his contributions toward a philosophy of complexity. The chief takeaway from these thinkers is condensed in Sasha Kagan's epigram: a culture of sustainability would be a culture of complexity. That is, a culture that accepts participatory complexity in its worldview is a prerequisite for a culture that can live sustainably. Let's explore why that might be true and why we don't have that culture now. In this talk, I don't have time to fully discuss complexity, but there are some ideas to keep in mind. And you could think of living organisms, societies, or ecosystems as examples. Complexity is about systems that are intrinsically diverse and necessarily open. Their character depends on the relationships among components rather than on the properties of components. Their openness and relational character combine in autoecopoiesis. Relationships are constantly rebalanced internally and with the environment. Complex systems accumulate patterns and behaviors over time, so they have to be understood historically. You can't understand a complex system only in the now. It requires an understanding of the past. The last two, nonlinearity and emergence, are at the crux of why complexity has been sidelined in our thinking, because they create some uncertainty and some unknowns in the way we can see things. Terms are needed, but we should know what complexity is.
It's HDMI cord. All right. Let me just reshare that for you. Sorry about that. There you go.
Okay.
Should be good now.
Cool. Thank you so much. So terms are needed, but we should also have something to look at. And in this slide, we see some ecological relations in nature. And they're of interest because, of course, complexity is an integral part of the way nature functions. It's a signature of life. Standing at the Stadium Road entry to the Gordon area, you can easily compare the woodland with the human-managed landscape outside. You can recognize many elements of complexity inside and few of them outside. As alluring and powerful as a trip to the Gordon area might be, we can become trapped into thinking about complexity as an objective aspect of our world. Why shouldn't we? let me show you a different way of looking, which I was alerted to by Manuel Lima's 2015 TED Talk. In this slide, and many of the following, I use vision as a metaphor for how we tend to think about and look at the world, our worldview, and not the physical ability to see. Lima shows David Levine's visual food web with its many rich interconnections among species. But look at the title of Lima's talk. It's not about cod, fish, or the ecology of the oceans. It's about the way we think and visualize systems. You see a food web. Can you also see an epistemological web, a representation of how we think about the world and our place in it? I believe we need to practice a way of thinking that's analogous to what we experience visually in these examples. Each image presents two possible interpretations, which can be brought into mind alternately by adjusting our attention. Can you see them? Probably yes. We can't say whether the image is of a duck or a rabbit. Both are there to be seen, but we need to learn to direct our attention in particular ways to see them. Likewise, we want to take our models of the objective world and also see in them models of our thinking. Our mental models of complex systems make a difference. This simple model of predators, seals consuming prey, cod, caused millions of seals to be killed. And the situation didn't get better, it got worse. Hypoxia led to the loss of many kinds of sea life. Details are given in the Pilkey's useless arithmetic. Levine's visualization of the marine food web on the right was meant to call attention to the rich and complex relationships among marine biota. It extends from microorganisms such as plankton to the atmosphere above the ocean where birds of prey are preying on fish and one another. I think we also understand that the box around this diagram does not actually confine the relationships, which could be extended to include hydrothermal events in the deep ocean and relations with terrestrial organisms. It might be hitched, as John Muir put it, to everything else in the universe. We're also struck by the virtual impossibility of constructing a practical, predictive model of such a system, given the need for data and the amount of computing power and time needed. While complex systems seem to have no limits, our thinking about them surely must. And this is the crux of our problem. How should we place the boundaries of our models? In the modern era, a prevailing idea has been make the model as simple as possible. We could explore this with numerous examples, and maybe you have some of your own. Coastal geologist Orrin Pilkey and others expanded on the implications of useless arithmetic for coastal modeling in a paper published in 2013. At issue is a simplified model of coasts that became widely used in coastal engineering to stop beach erosion. The boom or bust in their title conveys the good intention, bad outcome situation I mentioned before. The abstract explains that the reduction of complexity by modelers is problematic, not the complexity per se. That the problems are not quantitative errors, but qualitative errors that lead to a false sense of reality. And that the effect of such errors has been to make coastal engineering a weapon that harms the very coasts we're trying to protect. Oversimplification of natural complexity can turn what was intended to be a societal good, into its opposite. Victor Baker reached similar conclusions about famous engineering failures in history. They resulted from designs that didn't capture real-world complexity. Why do we have such difficulties with complexity? According to Roberto Poli, societal decision makers demand solutions that promise definitive, lasting results. In other words, they assume that the world is complicated, not complex. This expectation is connected to the way Western societies developed and to the idea that prediction and control are vital and that complexity is a problem to be solved. Joseph Henrich finds that the societies that have had the greatest influence in shaping our world are weird: Western, educated, industrial, rich, and democratic. These societies grew comfortable with a non-complex existence. People became more analytical, individualistic, and impersonal. As individuals and objects began to take precedence, relationships of all kinds, a necessity of complexity, were seen as less important. In the 18th century, Isaac Newton's philosophy of nature and time furthered the transformation of the Western worldview. A complex world in which people were participants became a separate world that people analyzed and studied objectively. Relationships in Newton's world are flattened and reduced to those that depend solely on the properties of the objects involved. Gravitationally, only mass matters, whether we're talking about an apple, a cannonball, or a planet. Time is absolute, abstract, and quantifiable, and its relationship to human experience is coincidental. A mechanistic worldview led to an engineering mindset. Designing and constructing bridges, dams, roadways, and machines like those in the flax mill shown here helped to suppress the nonlinearity and novelty of complexity. As machines became more complicated, having lots of parts, they became symbols of the human success story. The epitome of technological complication is called rocket science, and despite the half-century since the first moon landing, a moonshot aims to do something that seems almost impossible. Machines are a ready metaphor for our intention to make our world predictable, controllable, and perfectible. The machine metaphor is everywhere, all the time. Perhaps we're coming to believe that the world is just a house, not our home, and that technology can perfect water. And these pictures were taken just in the last few weeks, right here at WCU. Our ideas about sustainability are also trapped in the machine paradigm. This image comes from the first version of Awakening the Dreamer I used. The intended message, I think, is that humanity has only one planet, and if any part of it fails, we'll all feel it, and it's folly to get comfort from the fact that disaster hasn't hit us yet. Another, less obvious message is that sustainability is analogous to fixing our boat. It implies that sustainability is an engineering job. We need to repair our boat, build a stronger boat, design a safer boat. Another image you might have seen at WCU, if you remember some of Paul Morgan's presentations, we're led immediately into thinking about the design of these tracks. What kind of a crazy engineer or surveyor did this? We certainly can design a better railroad. We see our engineering failures and think we can engineer our way out of them, when engineering cannot begin to provide insight into our problems with complexity. Ways of representing sustainability, such as a Venn diagram, a three-legged stool, a triple bottom line accounting, are all set within the familiar world of human design and planning. From a mechanistic worldview, the search for sustainable living seems to prioritize confronting our unsustainable engineering failures. Some of the areas on this list are critically important and do require urgent attention. But if our goals are limited to preventing or repairing the problems we see now, we will never live sustainably, which requires a different worldview. It's difficult to think outside the cultural mainstream. We're encouraged in so many ways to keep it simple, stupid, and to try to eliminate complexity as though it were a problem. Yet the long-run outcome of avoiding complexity has been environmental disaster. Except for weird Newtonian thought, all systems on Earth, including our physical selves, are complex. Complexability is searching for ideas that can inform us and inspire us to create a sustainability congruent with complexity. To begin, let's consider a general strategy for modeling complexity. Models are the way we frame systems to understand them. They can include, but are certainly not restricted to, a formal quantitative model, such as those that might be used to predict the population dynamics of codfish. The work of Edgar Morin and Paul Cilliers suggests that there's always a trade-off. It's impossible to model the world in its full complexity because the model would end up as complex as the world itself. It couldn't be considered practical or useful. On the other hand, if we restrict our models, we may take out too much complexity and end up with the situation in Pilkey's example, where we actually create something that's worse off than we would have desired. Decades ago, when then geography professor Joan Welch and I were teaching a modeling course, we were influenced by John Hart's 1985 book, Consider a Spherical Cow. The spherical cow is meant to parody oversimplified models. The arrows represent the possibility of moving a conceptual boundary that determines how much cow and how much spherical cow we want in our models. Let me repeat the last words. How much cow and how much spherical cow we think should be in our models. We have to make decisions about how much we want to restrict complexity in our thinking. If we think that somehow the experts, past practice, data, or logic have already determined how to set the boundary, we may be following a status quo that is not considering the possibilities of greater complexity. Paul Cilliers proposed that decisions in complex systems amount to ethical choices. Where we put the boundary has consequences, and we can't ignore the responsibility of making those choices. The effect of complexity in making social policy was the subject of Riddle and Weber's seminal paper on wicked problems, published in 1973. It was neatly summarized by Richard Heinberg on its 50th anniversary. Though their 15-page paper uses the word complex just 3 times, it's all about complexity and the ways we fail to deal with it. Because our societal sense of problem solving follows Newtonian ideals, it works for tame problems, but not for wicked ones. And wicked problems is all we got in sustainability. The best guidance I've found comes from Paul Cilliers and his collaborators. Cilliers was a scientist whose interest in computer systems was awakened, and complex systems was awakened through research on pattern recognition and neural networks. But it was the philosophical aspects of his research that interested him. He wanted to explore the implications of acknowledging the complexity of the world in which we live. He was not interested in a philosophy that would only be of interest to philosophers. I rely heavily on Cilliers' work because I can find ways to reveal and avoid the perils of oversimplified worldviews. Let's return to South Campus, but not to the Gordon area in the distance, but to the varsity softball field. Why? Softball allows us to see some valuable characteristics of a restricted complex system. Though illustrated here by some specific actions and situations that occur during a game, I'm going to look for the duck by focusing on some of the complex relational and temporal connections that make a game possible. If you just gave the bats, balls, and other equipment to a diverse group of people unfamiliar with softball, what would happen? Many things possibly, but it wouldn't be softball. Softball is a highly restricted, complex game governed by rules and conventions that have been evolving since 1887. Nearly 140 years of playing and rulemaking have created a game that is, if I can change my view a little bit, read that. that is athletically challenging, yet safe. It is feasible to fund and manage at a variety of institutions. It provides enjoyment and pleasure for both players and the spectators. And in any individual game, the unpredictability and novelty of complexity are on display, despite the restrictions of all of those rules. For example, in the lower left corner, we see that WCU is down 0-4. But what you're seeing occur is actually a 2-run homer in progress in which WCU is just starting to come back, and they won the game 5-4. How unexpected is that? That's complex systems for you. And yet you can restrict them and have fun and still have all of that novelty. Here's a little quiz. Can you match each sport with its goal? Yes, you can. And I'll bet you did perfect. Even if you're not a major sports fan, I'll bet you can see in your mind's eye the action that precedes a score, such as the players moving the soccer ball, the football, the basketball, or the puck to score a goal. But can you imagine the Eagles using the tush-push to sink a three-pointer in the hockey net? No, that's ridiculous, isn't it? And the reason that's ridiculous is because the game that's being played has nothing to do with the goal that is there. And so the play of the game and the goal have to evolve together. And this is at the crux of what I consider complexability, finding goals for ourselves that are consistent with the complexity of life. And many of the goals we have in our sustainability area are actually based on the idea of linearity and engineering rather than in complexity. So we can't define our goals until we understand the game we're playing. We're inevitably playing a game of complexity. One of the other characteristics of weird societies is that they're well educated. And here we are, many of us engaged in one way or another in education. And education's important because it's the leading ideas and the worldviews of our society are systematically strengthened, refined, and passed on through education. The formal structure of a university emphasizes the analytical, quantitative, predictable, and the universal, as symbolized by engineering, rocket science, and the moonshot. I don't mean what is taught. That can vary a lot by discipline, but by an environment in which standardization, quantification, linear sequencing, and rigid hierarchy are all ingrained. There's no room for complexity in the running of a university, apparently, and students, staff, and professors learn this well. Meanwhile, sports, which might be used to inspire more complex ideas, are co-curricular and not required. If our goal is to foster complexability, how should we proceed to reach a balance? Cilliers provides an important idea. We cannot expect to find universal, one-size-fits-all answers. This is probably a disappointment because our attention in education is on standards, best practices, and broad generalizations such as student success and lifelong learning. Complexity, though, arises from the particulars of local relationships, and each of us is at the center of such a web. We are particular people teaching our courses to a changing group of students. We have to find out what will work for us. You can't know what to do from hearing a lecture or reading a book. The good news is that if we want to teach from a complexability perspective, we don't need to change what we teach as dictated by our discipline or personal interests. What we do need to do is to think about the philosophy we bring into the classroom. We all teach with a philosophy, and it's predominantly one compatible with the weird Newtonian worldview. How do we change that? My dad worked much of his life as a machinist for a corporation that made knitting machines, comparable to the amazingly complicated one shown here. His job was to make sure that all parts were made to exacting specifications so that the machine would run exactly as intended. In a machine this complicated, joints that are too loose can make the machine fail by giving the mechanism too much play. In classrooms, such as the one shown here, we see the educational equivalent. Each student is there as an individual part, and their interaction with one another during class is tightly prescribed. Their syllabus lets them know exactly what will occur in each class period and tells them the course requirements and the consequences for violating them. But neither students nor professors are parts of machines. We exude complexity, as do all living creatures. We don't want students to run wild in the classroom, but we can nurture complexability by finding ways to let them understand and appreciate their complexity. Buckminster Fuller's maxim has appealed to me since I first read it years ago in John Ehrenfeld's book, Sustainability by Design. The thing about tools, be they mechanical or computational, is that they don't do anything without the participation of those who use them. And by participating and reflecting, their understanding might change. An attractive idea, but does it really work? Let me tell you a personal story. 35 years ago, in 1990, I participated in a multi-day workshop, Fractals in Geology. The focus of the workshop was not the theoretical or aesthetic aspects of fractals, which were well known then, but with analysis of data, such as fractures, streams, coastlines. The tools I learned to use quickly led to publications. Ultimately, they led me to a radically different understanding of fractals and complexity. I might never have come to this understanding without the conceptual and practical tools I learned to use. To illustrate how the tools worked for me, let me start with a seminal problem in fractal analysis. It begins with a question: how long is the coastline of Britain? At first, this may seem like a simple thing to find, a fact you could look up. A line separates the blue of the ocean from the lighter colored land. Measure its length. But if we zoom in, we find a coastline that has irregularities on every scale. They can't even be seen on the map. What the line between the ocean and land looks like changes as the scale and resolution of the image and the measurement changes. If we measure at different scales, we find that the length is different. The relationship between the scale of measurement and the length of the coast is what we call fractal. But again, to ascribe the relationship only to the coast is like seeing the rabbit. In duck view, there's a human participant that makes up one part of the relationship as shown on the x-axis. Human choice is involved and is the participatory connection that makes such an analysis work. The coastline does not even have a length until someone measures it. One of my attempts to have students learn complexability in the classroom comes from subject appropriate to tools, in my case, the analysis of geologic data. If you want to know the average precipitation in Pennsylvania, you can look it up. But this is one number, and it's based on an average of 30 years worth of precipitation measurements. If we define the average like that, there's no play to it. That's the number. The data are restricted so much that the liveliness, changeability, and unpredictability of rainfall is squashed down into a single answer. Averages and other statistics are a way that weird Newtonian societies make the world look simple. To introduce play into my class, I give students an Excel tool that lets them calculate moving averages. They can choose various data sets and then choose a time span for the average, which is like choosing the scale of a fractal measurement. In the case of the precipitation data, I have students select a number of different averaging spans. They save their results, and we share these with the class. Here's a diagram that shows a few of the results, and in them, we can see different features of precipitation history over a range of timescales, from irregular rapid changes using a 3-year average to the longer-term changes using a 50-year average. These are the rapid. But I also want to make sure my students try to look for the duck. Using the tool lets students see themselves as part of the systems they explore. It's through their interventions and by exercising their choice and judgment that they can create meaning from data. There are no correct outcomes to achieve. By learning to play with the restrictions, they become explorers. By reflecting on their play, they become aware of their role in complex systems. Another controlling idea that has come to dominate modern societies, Isaac Newton's conception of time. Time that flows equably without relation to anything else has become the independent variable against which all temporal change is shown. Time on the x-axis, everything else on the y-axis, just like in the last slide. Think of how many charts you see that follow this pattern. This chart portrays changes that occur in Brandywine Creek after a rainfall. Flow is the rate of water movement. Conductance, the concentration of dissolved ions in the water. Turbidity, the amount of suspended sediment, which can make the stream look muddy. You can see each of the lines on the chart separately, but what you can't really see is the relationship among all of these variables as the stream evolves after the rainfall. An Excel tool produces this chart, which shows the same data as the last slide, but there is no time axis. Instead, the changing relationships among water, ions, and muddiness are front and center. They mark out a closed hysteresis loop starting and ending in the upper left, and the direction is indicated by the arrows. A slower pace of change is indicated by a closer spacing of symbols. The dance which these data perform shows different parts of the hydrologic system, rain, runoff, and groundwater interacting to form a stream. I think that a mind that learns to see a stream dance like this is also learning to dance with complexity. In living systems, autoecopoiesis, the ability of boundaries to adjust dynamically to meet the needs of the system and its environment, is essential. Think of your skin or the surface of a leaf. Such boundaries have evolved through time to be able to balance, separating, and connecting. The paradigm of weird Newtonian thinking is that we can learn to control system boundaries arbitrarily and absolutely. Here's an example that suggests how we can find our way toward renewing our mental autoecopoiesis. The weird Newtonian way of thinking restricts important decisions to subject experts. This diagram that deals with flood control and risk communication shows that much of the responsibility is given to experts who emphasize the importance of disciplines, quantification, the rationalist paradigm of probabilistic and analytic thinking, and top-down management. The boundary represents a strong restriction on meaningful communication and interaction of experts with the public. And the result is a public that lacks knowledge and a strong voice in flood management decisions. How can critical complexity help us see this differently? Cillier's work guides us to think of the boundary of responsibility as responsive to our needs. We can begin by seeking necessary connections between objective and subjective ways of knowing. Complexability, indicated by the double-headed arrows, involves finding subjective counterparts to well-established objective concepts. For example, we can look for synergy between disciplinary and transdisciplinary research, and between rationalist paradigms and constructivist ones. In my 2024 paper, I show how bringing analytic and probabilistic thinking together with experiential and possibilistic thinking leads to new ways of communicating flood risk. We can replace the obtuse message of the 100-year flood and similar constructions with charts that allow people to apply their own individual situations and ideas about risk aversion. I want to emphasize that critical complexity doesn't dictate that we replace objectivity with subjectivity, but that both are necessary in order for us to live sustainably. Let's move toward a closing. Throughout my presentation, I've used balancing as a visual metaphor for complexity, but it does have problems. The two ends of the balance remain separate and distinct, and the equilibrium can't be maintained if conditions change. I'd like to give you a better way to think about it. Weird Newtonian societies have gotten used to seeing the world through just one eye, a simplifying eye. And it's difficult to construct a holistic view of the world if one has only one input. Complexability means using and strengthening the vision in our complex eye. Instead of seeing two things differently, our brain merges simplification and complexity into a single image of our complex world and our place in it. Paul Silier's insights into complexity can be condensed into a very simple phrase: use both eyes. We have to learn to think and do things differently to avoid retracing the paths that previous generations have set us on. It's easy for us now to see the surprising and unpredictable aspects of complexity as undesirable, but developing complexability may be just what we need to discover surprising and novel ways to live sustainably. Einstein did not say many of the things attributed to him, but he did say that perfection of means and confusion of goals characterize our age. My favorite expression of this idea comes from Joel Salatin in Food, Inc. I'm always struck by how successful we have been at hitting the bullseye of the wrong target. We become a culture of technicians. We're all into the how of it, and nobody is stepping back and saying, but why? I think that complexability gives us the vision to aim at the target of living sustainably. We might not hit the bullseye much at first, but I can't see the point of continuing to shoot at the same ones we have been. Finally, I think we have every reason to be optimistic about gaining complexability. As much as we try to eliminate complexity in our lives, it's always there, waiting for us to open our minds. Think globally, act locally is sometimes attributed to René Dubos, but a more germane saying of his might be, trend is not destiny. The weird Newtonian worldview may seem unshakable, but it's not a fixed, essential, or immutable feature of society. Societies evolve, and we, especially as teachers and students, should be essential participants in that evolution. Thanks.
They have questions online, but in the meantime, questions here?
Yes.
Well, that was such a complex analysis that I'm just speaking by it, and I'm trying to put it together in a maybe a little more simplistic view so I can digest it better. Because 2 weeks ago, we had a presentation by Daria, and she's the cop, right?
Mm-hmm.
And she was also showing how the world has changed from the beginning until now. And, you know, all our knowledge and whatever we discuss is only the 30 years or the 100 years.
Mm.
And so she was showing millions, but we don't know much about. We think we know something. And that was all before humanity even existed.
Mm-hmm.
And if we accept that and understand that, we also have to understand that we are just playing the minute little detail something in this whole life and in this whole world. And therefore, you know, we could go to the extreme, what all can we do to save this? You know, all these 5 things that we used to do. The opposite is, when you give up, it's too complex. You have to do something. And I think the minute you raise questions about going outside of the simplistic worldview, people already start attacking. Like that was, I felt, the response 2 weeks ago when I mentioned maybe, you know, we can never solve these problems. And we also have to understand that we are not the master of the universe, that we can solve everything. And maybe we just have to succumb to, I don't want to say a little puppet, we can do something, but we really cannot solve all of this. So that it comes down to that as well. But the minute you open the philosophical discussion on that scale, people just shut down because it's too complex.
Well, I think you mentioned the problems with feeling that we can't solve anything. And I think that's exactly what complexability is about, realizing that we don't have to solve everything. But what we do need to do, I think, and you know, I understand, obviously, earth scientists, I understand the long scope of history, but you know, we are here now. You are here now. And so I think that what we should be thinking about is what we can do. And my perspective in this talk, which I hope came across from presenting my own personal involvement in classroom experience, is that what we can do now is to try to think about a better future. And my point would be the idea of solving problems once and for all, lasting solutions, best possible, best practices, has not worked for us in the past. And I think we do need to get into recognizing our complexity. Complexity is not a deep problem that we need to solve. Complexity is here. It exists in this room, within each of us, among our relationships that extend outside of this room. You know, what are we doing with those relationships? I think we need to examine them.
If I understand it correctly, what you have also shown is what humankind have produced, trying to make a better future. It has actually not achieved that goal. Okay, because it's always good and bad at the same time. You know, the World National Area, you're preserving the beautiful land, and then you have the other paved road and the shed there, all of that. So, are we actually capable or able to produce a better future? Aren't we just as human beings maybe thinking what we could do is we cannot do that because whatever we do is always positive and negative at the same time. There's never just a part, it's not just. So what is better even mean?
Well, I think the idea of complexability is that we need to have appropriate goals. And I think the idea that confronts us with sustainability is that we are living unsustainably, right? I mean, I don't think there's much dispute about that, right? And so we have somehow missed an appropriate way to live in the world. And I think that that is something that we can aim for. We can aim to do better, and we can adjust our goals so that instead of trying to avoid things absolutely, which is the problem with engineering, right? I mean, we make plans and we think, got it, build that bridge, it's perfect, it'll last for 100 years. And we realize that maybe that's not the goal we should have for living sustainably. Maybe we need to, instead of thinking of things that will work perfectly, we need to think, how do I do things right now?
But have there ever been in human history, people that were able to do that. I think in the history of humanity, there is not a tribe or and that were ever able to do what we're trying to achieve.
I don't know that that's true. I'm sorry. I think if you look at the way society for 10,000 years lived on this continent, it obviously wasn't perfect, but it was much more sustainable. And the reason that I think that's correct is because the human population on this continent was so low. The thing that is, no, but that's not a given. It's an outcome of a society that was actually living sustainably. The truth is this planet probably cannot support 20 billion people or 15 billion people sustainably. But the North American continent probably could sustain 1 million people sustainably.
We should continue this conversation, and I hope, Tim, you have a few more moments, but we are past 12:50, and we normally pause at this point because some students and faculty have to leave to get to a 1 o'clock class. So if you have to leave now, or if you have to log off on Zoom, please feel free to do so. If you'd like to continue the conversation, stay, but before you go, please join me in thanking Professor. And I know that Professor Wanko is on the Zoom and has a question also.
Thank you. And if someone else in the room, has a question, I will cede the floor to them because I always ask a question. So are there questions in the room?
You can go ahead, Cheryl.
Okay. 2 points. First of all, you focused on the idea of kind of relationality at the end, and I would posit that that is the way that we are already addressing complexity, because complexity for one human brain is very difficult, as you also demonstrated. And so the way that we address complexity in our society is through multiple brains working at once. So instead of the single scientific study, the meta-analysis. So instead of one director of sustainability, we have a sustainability council. Everybody can't do everything, but everything, everybody needs to do something. So that's my first point. And the second point is simply art, right? Because art is a way of dealing with the complexity of the world that I think might need some more attention here. Thank you.
I would agree with Cheryl in the sense that certainly in the idea of having multiple minds involved, this is good, provided that the minds are not all thinking of the same sort of solutions that we've all been thinking of. And so I think one idea is that, yes, these structures that we developed are great, but I think if we want to move further towards solving some of our problems, maybe we also need to think about incorporating some different ways to orient those minds. So I know that the Sustainability Council, for example, is oriented towards some things like transportation, landscapes, buildings and energy, and so forth. All of those things don't require complexity. So what could you build in to that type of a council which actually gets people thinking outside of those little boxes in which we tend to put our energy? I think complexability is not actually that hard, but it requires getting our minds free from just the usual stuff in which the usual alleys down which our thinking tends to run, and to be able to think in different ways. Mark, I saw you had a hand up.
I have too much to say. It's fine. I will point out a couple of things. AI, generative AI, the kind of AI that ChatGPT uses now, is interesting because it is sort of inherently built on complexity. And the second thing that I wanted to point out that struck me as ironic. If you go back a couple of slides to the work that you did
Can I do that?
Flood risk.
Yes.
I was immediately brought back to the situation this summer in Texas where all of those campers died.
Yes.
That wasn't a flood risk assessment problem.
No.
So what do we do about that?
About.
Meaning that we understand flood control and even risk communication to a certain extent, that obviously could be improved.
Yes.
But then other factors break things down so that the outcome is so far from what we wanted.
Yes.
And I just wanted to bring that up as one of the many obstacles towards operationalizing this kind of thinking.
Well, I think that one of the problems that came out in that Texas situation, which was so tragic, is that there was a lack of obvious communication at the time. But beyond that, the people who were attending that camp and their parents and the people who were part of that community, they weren't even necessarily thinking that they were at risk, right? And one of the problems with flood risk communication is that we tend to communicate with the people who we think are at risk. We say, here's a community, they're in danger, we need to educate them. What about the rest of us? I mean, one of the issues is that flood risk is not a thing. It's an aspect of risk that pervades all of the natural and human systems around us. So I think one of the ways that complexability comes in is by not teaching risk as a targeted thing, like you're at risk, you should know this, but by making us all more aware of our situation within this complex world. So, and I think that's, again, where education comes in, not at the level of the immediate point of impact, but where it comes in earlier on, where we can get everyone thinking more about the nature of risk.
And you know that they're going to rebuild that camp.
Oh, yes, but better, safer. It'll be higher. Yes.
It's like very abstract for me. So like for like more concrete things, like we have like already unsustainable like bridges, dams, things like that. Like then how do you propose fixing unsustainable solutions? Because like if we were to make those things more sustainable, we would have like even greater like environmental impact because we're gonna have to get more materials, bring more labor, like just use gas vehicles to like just use this thing. So like the associated like environmental costs of making the things that we have that are unsustainable like more sustainable, is that like feasible like financially, like economically, like that kind of stuff?
I would say I don't have any idea, but I would also say
That's honest, that's honest.
I would also say that the things you are raising there sound like you're thinking of sort of an oppositional type of thing. We could do this, but then we need to do this, and that could actually work against us. Now, that is exactly the kind of thinking that I think leads us to confront questions of complexity, because I don't know. I suspect that we would need to have some trade-offs, but you know, understanding that the way we have it now and the way that we simply put experts in charge of things and say, you guys figure that out for us, that's not going to work. And so raising questions like this, hard questions where community would actually need to talk, decide priorities, expenses, you know, safety. Those are the kinds of things that that can come out of sort of seeing things in a different way. Yeah, well.
Yes, I was wondering if you drew any parallels between your looking at things with two different eyes, weird eye and that's a good eye with Ron Walker's great sweetness.
Well, I used to use Kimmerer's sweetgrass in my classes, and I don't know that I directly got that from Robin, but I wouldn't be surprised if she influenced a few neurons in there too.
There would be the indigenous knowledge approach be.
Yes.
for Acknowledging complexity.
Yes, well, and I think it's important to note, as Mark was saying earlier, indigenous knowledge predates weird Newtonian thinking. And so I think to find examples of how things might be, if we look back, we may find situations that tell us about how people lived when they had a more complete vision for the natural world and their place in it. It's only a few hundred years of stuff that's covered up.
2000, okay.
Well, maybe a few things, but even so, I mean, I think we have a chance to think beyond all of that more recent way of understanding. Yes.
Well, the scientific method has always kind of taken a complex situation and eliminated some of the variables so that you have a model that you can control and come up with a solution. And I'm thinking that maybe we need to kind of step back and say, yes, this is what we tested. But if you think about all these variables, we may have ended up with different results. And as scientists, to acknowledge that what we're doing isn't perfect, even though it's peer reviewed, even though it's best practices, just to acknowledge that it's not perfect and that, you know, if some other factor were looked at, we could have ended up with a totally different conclusion based on what we did.
Sure. And the great examples of this, I mean, I think something that comes to mind that I think is important is that, for example, you probably heard a few years ago, there were news stories about how automobiles in the United States were designed primarily for male bodies. It's not that they couldn't have taken into account the size and shape of females, but they just didn't. And likewise, the way that many of our experiments in health, medical trials, pharmaceuticals are carried out primarily on certain populations and not others. The whole premise of Joseph Henrich's book, Weird Societies, is that we are weird. You don't realize it, but read his book. It's rather astonishing how different we are. And he would say unabashedly, you're all weird. And he knows you're weird because we're all literate. And literacy is a big part of Henrich's theory of how we have developed, particularly in the Western world. And it's all, you know, sort of, there's all of these things that we see and fail to see at the same time. And it's really interesting to contemplate what we would see if, or let's say, what doctors and medical researchers would have seen and how we would be living differently if some of those conceptual boundaries had said, yeah, let's consider Black people and Asian people as well as the white population. It would lead to different places. So recognizing the boundaries that keep us apparently from looking is one important part of complexability. It just opens things up to possibilities that we don't even understand.
And that goes back to, I think a lot of the studies were done by white males, and so they thought about themselves. And when you don't have that diversity of researchers, you didn't have Asian women and, you know, Black men as part of the team, then those people may have kind of gotten more consideration. So it kind of extends into so many other silos that we see on campus that really aren't silos, they're really interconnected.
Yes. But, you know, as I, you know, said, in education, we're very good at silos. That's our number one ability, I think, yeah, the one.
Just following up on that, health and medical metaphors. It struck me as you were talking that it's also the difference between a model in which the body is a machine that can be separated into component parts. Each component becomes a specialty. There's a system around that component, but it's not, the system is not. The point is the optimal function of the component. And I think about the heart as the prime example of that, you know, the heart as a pumping machine. And that metaphor, I think, is at the heart of Western medicine. But it's not the only way to think about it in the body or medicine. There's a whole, and I know very little about medicine, so I'm not going to say very much because I'm ignorant about it. But there are other ways to think about it, so in terms of energy flux, which not only, I mean, there are no components per se, right? It's a completely different paradigm. Each one of those approaches has had tremendous successes and also limitations, but what they have is very different restrictions, just a very different mindset. And so I think in Tim's talk, my thinking about this is it's about asking a bunch of really difficult questions about how things are connected. And you can't do that in isolation. You have to have large numbers of people, just like Cheryl was saying. And it's about paying more attention to the connections and relationships, which is what was on one of Tim's slides earlier in the talk, and less about individual things. It's not that the individual things aren't important, but we'll re-examine them all, and it's really hard. These are really big problems. So acknowledge it and not, it's not a teeter-totter, it's more like standing on a balancing ball. There is no stable, a teeter-totter reaches a stable, but you can't move, or you upset the teeter-totter. Balancing ball, there is no stability. Every instant you have to adjust. But in that adjustment is all of the benefits of balancing ball to your body.
I think we would use our time very differently if we embrace the challenge to live with the complexity, the complexity of life. You know, so much of what we do is predicated on the fact that we're busy, we have this task and this message to write, and that person to see, and
We don't have time to get into the weeds on all the things that are connected to us.
Stay all day, it's a real breakthrough.
Right.
No, we're not.
One of the references in my last couple of slides that you didn't get to see is from Barbara Adam, who's a writer. She calls herself the philosopher of time. And so she refers to industrial time as the kind of time we live in now. And her point is that we are so restricted by our conception of time. You know, as you were implying, you know, how long can I talk? Well, the section is 50 minutes long. That's how long you can talk. How long is a class period? How long is a semester? How many years do you spend in school? All of these things are blocked out in terms of this time that we made up for ourselves, but we just made it up for ourselves. And we can think about ways in which that could be different. And that would be a major conceptual boundary that we would be addressing if we were able to think how to run a university in a way that didn't have such limitations to conversation, right? The ability to learn things from one another.
So when is the book coming out?
In a little while.
Well, thank you, Ted.
Yeah.
Thank you so much.
You're welcome.
There's so much to think about.
Well, that's good.
Yeah, no, that is.
And I think it's